All right, guys. Continuing on, we are doing testing the confidence interval. We're putting our eye on the slope now. This falls into section 11.4. So there's two ways we can do this. We want to know if the slope or if x really has anything to do with the values of y. Well, one way to think about that is if x had nothing to do with y. An easy way to measure that is then the slope would have nothing to do with y. So what we're going to do in this section is turn our eye on the slope. We're going to see if the slope has anything to do with y or not, and how we're going to do that is we're going to test or see if the confidence interval contains 0. If it contains 0, then it's possible that the slope is 0, which means x has nothing to do with y, and there's no linear relationship possible. I'm going to show you two ways to do it. One with a confidence interval. If it contains 0, then linear regression is not an option. And the next slide, we're going to test a hypothesis using a null and alternative hypothesis, which you guys are familiar with from previous chapters. So let's look. Again, I've got all of my equations here on the left. The one that we need to look at here, this little guy is always in my way, is this one right here. Couple of things. We are looking at 95% confidence interval of alpha over 2. That's a t at 0.025. That's 0.05 divided by 2. And our degrees of freedom in this case is n minus 2. So it's going to be 12. Using table 3 for t of 0.025, degrees of freedom of 12, I found, using that table, 2.179 is going to be our critical value. So 2.179, 2.179. So we, looks like that. Okay, now we've got our slope plus or minus this value that we just found times s with a subslope b1. And what that is the standard deviation that we found divided by the square root of the standard, the SSSXX. Okay, so if we do this, S beta 1 equals 9.0917 divided by the square root 0.00211. I get 197.9265. Times our critical value, 2.179, and that is 431.33. So what did we just find? We found that the confidence interval for our slope, beta 1, is going to be between 554.5 plus 431.33 and 554.5 minus 431.33, or basically 123.1. Oops. Should be 954, 985.8. So within 95% confidence, we can tell you that the slope of the line that best fits the 14 Major League Baseball teams' batting averages and wins is between 123.1 and 985.8. This interval does not contain 0, so we can assume, based on this, that there is a linear relationship between the two. X does, in fact, make a difference in the value of y. It does not contain 0. It is a pretty wide range for the slope, but based on our scatter plot, there's a number of best fit lines that we could put through there. Okay, so that's one way to do it. The second way is doing a hypothesis test. And we're doing it the same way. We got a test statistic like we did before. And what we need to determine is what kind of null and alternative hypothesis am I going to do? Now, if you're just testing for a general linear relationship and you're not trying to make the prediction that it's a positive or negative relationship, then you just do the null and alternative equal, not equal. Some of the problems, I think a couple on your homework, say test the hypothesis that there's a positive significance on the value of y, meaning the slope is positive. In that case, you'd use the second or the third if they want it to be a negative slope. In this case, we are just going to say, not the mean, I'm so used to writing mean, you guys. We are going to say that beta 1 is equal to 0. Our alternative hypothesis is that the slope is not equal to 0. So we know our critical value from the last slide. That's 2.179. We can use our test statistic to determine if that falls within the critical region. And so our slope is 554.5 divided by, we did this calculation in the last slide, 197.93, and we get 2.80. So if we've got a value 2.179, our test statistic is 2.8. It falls within there. We are going to reject the null hypothesis that the slope is 0, meaning there is a relationship between x and y. The slope does contribute to y.